Hi class, welcome back. Today we're going to be talking about variables on both sides of the equations. This is lesson 2 from our unit 3. So what we're basically talking about today is we're going to be talking about three different things and three different learning goals by the end of this lesson. The first one will be you'll know how to solve equations that have variables on both sides. So right now we've kind of just been talking about one-sided variables, but by the end of this lesson you'll be able to solve them on both sides of the equal sign. And using the balance method as well. So this is a reoccurring theme we're going to have throughout this unit is using this balance method. You'll know how to move variables and coefficients, so both variables and coefficients along the equal sign using the balance method, and you'll know how to collect like terms, which we've already gone through, so this is kind of a review from then. So we're going to solve the following equation using the balance method. We've kind of already done this. This is a review from last class, but we're just going to go over it again. So with this a, you have 3x minus 10 equals 2. The first thing you want to do is you want to get this 3x on its own. So what I'm going to do is I'm going to do 3x minus 10. In order to get rid of the minus 10, I'm going to have plus 10 because negative plus 10 is equal to 0. Then whatever I do to this side, I have to do to this side. So I'm going to do 10 plus 2. So I'm just going to add the 10 at the other side. And so negative 10 plus 10, these cancel each other out. So I'll be left with 3x plus 0, but we don't write that in, is equal to 2 plus 10, which is 12. And that is my answer. Right? That is my answer for what 3x is, and then I always want to isolate and get x by itself. So what I'm going to do is I'm going to do divided by 3 because it's 3 times x. I'm going to do the opposite. Cross out the 3's. X is equal to 12 divided by 3 is 4. And that's my answer. So it's always going to be x is equal to, or a is equal to, or whatever it might be. Now I'm going to move on and I'm going to do b. Same idea. So if this is something that you can maybe try doing by yourself first, try going through it by yourself. I'm just going to obviously put the solution for you to watch after. So you're going to have 5 minus 2a equals negative 9, right? So you're going to have, bring over that, you're going to get rid of that 5. So when I say get rid of, I mean I just want to have it equal to 0 because I want to isolate the variable for a. So I'm going to do that by, it's positive 5, so I'm going to minus 5, and then whatever I do to that side, I got to do to the other, so I'm going to do 9 minus 5. 5 minus 5 is equal to 0, so I'm just going to leave it as is, negative 2a minus 9 minus 5, minus 9 minus 5, so you're just going to put that in and find the answer, so it's negative 14 equals minus 2a. Now I want to get this a by itself. What it's doing right now is it's multiplying by 2, so I'm going to divide it by 2 because I'm going to do the opposite. So a, whatever I do to that side, I got to do to the other side. Make sure that you divide it by negative 2 because it was a negative 2 here, and that matters. Negative 14 divided by negative 2 is going to be positive 7, which is equal to a. Okay, so that's what we're going to do using the balance method. The main goal is to collect the variable terms together and then all the constants together, and you can do this by using the balance method. You notice that all your a's are on one side and all of your just numbers are on the other side. So we're going to go on and we're going to try doing the following equations for variables, and we're going to show a check, right? So let's do a together, right? So here in a we have 7x, and this is where it gets a little bit more complicated. So you have 7x equals 5x minus 7, right? Those are our variables. So I just want to go back here and I'm going to highlight what my variables are. I want to get the 7x and the 5x on the same side. I'm going to say I want to put it on the left side just because I like all my variables on the left side and I like all my numbers on the right side. So I'm going to move. In order to get this minus 5 out of the right side, what I'm going to do is I'm going to subtract it by its own by its opposite integer. So if I have negative 5, if I have positive 5x, if I just subtract 5x, I'll cancel these two out, minus 7, right? And I'm going to do the same thing here. because whatever I do to that side, I got to do to the other side. So this will cancel, so I'll be left with negative 7 over here. And I'll have 7x minus 5x. So 7 minus 5, because they have the same exponent, I can go ahead and just collect those like terms together, right? Which we've already learned. So 7 minus 5 is equal to 2. X plus 5 is equal to negative 7. Now I want to move my 5 so I can get the 2x by itself, right? So if I'm going to get rid of the 5x, I'm going to do plus 5 minus 5 is equal to negative 5 minus 5. Plus 5 minus 5 is going to be 0, so I'm going to be left with 2x is equal to negative 7 minus 5, which is going to be negative 12. And then I want to get rid of the 2. So it's 2 times x, so the opposite of multiplied is divide. I'm going to divide here, and I'm going to be left with 2 crossed each other out. Negative 12 divided by 2 is just negative 6. So I know that x is equal to 6. Okay, if I wanted to check this answer, how I could do that is I could just plug back in negative 6 into this original equation. So I want to check it in orange. So I'm going to do 7 times negative 6 plus 5 is equal to 5 times negative 6 minus 7. And I'm just going to make sure my left side equals my right side. So let's figure out the left side first. So I have 7 times negative 6, which is going to be negative 42 plus 5. Negative 42 plus 5 is equal to negative 37. Right? And I'm just going to put an equal sign here for form. 5 times negative 6 is going to be negative 30 minus 7. Negative 30 minus 7 is negative 37. Those two sides equal each other, therefore this is correct. Okay. I'm going to move on and I'm going to do B. I'm sorry I did not give you all enough space to do this. And we're going to do B. So same idea, try doing this by yourself before you watch the solution and then go through the solution with me. So I have 8m here, right, minus 12 equals 36 minus 4m. The first thing I'm going to want to do is I'm going to want to move all the m's on one side, which means that I'm either going to get rid of an m over here or I'm going to get rid of an m on this side. I always like to have all my variables on the on the left side, as I stated. It's completely up to you which way you like to do them, but this is the way I like it the best. So I'm going to leave my 8m here. I'm going to leave my 12 there for now. 36 minus 4m, and I want to get rid of the 4m on this side, the minus 4m. So negative 4m, in order to get rid of it, I'm going to add 4m. So minus 4m plus 4m equals 0m, so you're just going to leave it. And then I'm going to add the 4m on this side as well, because whatever I do to that side, I have to do to this side. Equals 36. And then I'm just going to go in and I'm going to collect my like terms. So I have 8m plus 4m, which is going to give me 8 plus 4 is 12m, minus 12 equals 36. And now I want to get this m by itself, so I'm going to get rid of that 12. 12m minus 12. In order to get rid of negative 12, I'm going to add 12. Whatever I do to the left side, I got to do to the right side. So I'm going to add 12 over here. So 36 plus 12 is equal to 48. Negative 12 plus 12 is just equal to 0, so I'll leave that. So I'll have 12m equals 48. Now I want to get rid of this 12m and just make it just an m. And I know it's 12 times m, so I'm going to do the opposite, where I'm going to do 12. And I'm just going to divide it by 12. So I'm going to do 48 divided by 12. And that is going to give me m is equal to, because the 12s cancel each other out, is equal to 4. And if I had to check it, I would check it just the same way. I'm not going to do that for the purposes of this one, but you can try it by yourself. All right. So moving on, we're going to do number C, or letter C. Let's go through this one together. Right? It's the same idea. It's just different practice questions. I'm going to keep giving you the solution, and then you can just keep watching through these as it goes. If you understand this stuff and you get it, you can skip and just go on to the next set of questions. But I would suggest trying this by yourself. Sorry, I'm just going to make sure it's still recording. All right, so then we have C, 10D plus 12 equals negative 18 minus 5D. So again, I like to keep all of my variables on this side. So I'm going to move, or not move, I'm going to try to get rid of this negative 5 on this side. So I'm going to do 12 equals negative 18 minus 5D. Minus 5D, in order to make that a 0, I'm going to add 5D. And whatever I do to that side, I have to do to this side. So I'm going to add 5D over here. So that cancels. So I'm left with negative 18 plus 0, but I'm just going to leave the 0 out. Here I'm left with 10D plus 5D. I can just go ahead and collect those like terms. 10 plus 5 is 15. And then I'm going to leave the 12 because there's no D attached to it. So that means that I can't collect that as a like term. I have 15D plus 12 equals negative 18. I want to get rid of this 12, so I just have 15D left. So how I'm going to do that is I'm going to do positive 12 minus 12. Whatever I do to the left, I got to do to the right. So I'm going to have negative 18 minus 12 on the other side. And that's going to be negative 30. Positive 12 minus 12, that's just going to be 0, so I'm not going to write it in. 15D. And then I want to get this 15D, and I want to just make it D. So right now it's 15 times D. So if I want to get rid of the 15, I'm going to have to divide it by 15. Just do the opposite operation. Same thing here. Divide it by 15. Opposite operation. D is equal to negative 30 over 15, which is going to be negative 2. And it says to perform a check, so we're going to perform the check for it as well. So what I'm going to do is I'm going to make sure that my left side equals my right side. So I have 10D plus 12. I'm just going to do the check right here, 10D plus 12. And I'm going to try fitting it into a really small corner because I didn't leave myself enough space. So I'm just going to increase this right here. So I know that my D is negative 12. I'm sorry, negative 2. So I'm just going to plug that in. Plus 12 is equal to negative 18. Always put it in brackets. This is where that bracket starts to make a difference, right? Because it's a negative. So you need to make sure it's always in brackets. Okay, so let's do the left side first, and then we'll deal with the right side. So the left side is equal to 10 times negative 2, which is negative 20, plus 12, right? Negative 20 plus 12 is equal to negative 8. Now you have negative 18 times minus 5 times negative 2, right? The first thing you have to do is do this 5 times negative 2, which will give you negative 10. Again, leave that in brackets. You still have that negative sign on the outside. Negative 18. Another way you could have looked at this is you could have been like, it's negative 5 times negative 2, which will make your subtraction into an addition, so it becomes plus 10. You can do it either way, whichever way you feel comfortable with. But I'm just going to do it this way for our purposes. So now I can see that this negative and the negative will give me a positive, so it'll be 18 plus 10. Negative 18 plus 10 is going to be negative 8. Left side equals right side. Therefore, this is correct. Okay. Moving on. We're going to do number D, just so that you can go back and check it as well. So I have 5A plus 12 is equal to 3a minus 14, right? I'm going to want to put all of my variables on the on the left-hand side. So I'm going to move and get rid of this 3a over here. So 5a plus 12 is equal to 3a minus 3a minus 14, right? Because I want to get rid of that 3a. So whatever I do to this side, I have to do to this side. So I have minus 3a over here. So I'm going to do 5a minus 3a, just collect that like term. It's going to turn to 2a plus 12 is equal to 3a minus 3a, which was 0 minus 14. So I'm just going to go a step further and get rid of that right off the bat, and just to make it a little bit clearer. I'm also just going to make this a little bit clearer. Okay, so I have minus 14, and now I want to get this a by itself, but first I'm going to have to get rid of the number here. So I have positive 12. To get rid of positive 12, I'm going to minus 12 equals negative 14. Whatever I do to that side, I have to do to the other. So it's going to be negative 14 minus 12, which is equal to negative 26. So I'm just going to put that in, negative 26, right? And then you have negative 12 plus 12 is gone, so I'm just left with 2a. After that, I'm going to get rid of this 2 times a by doing 2 just over 2, so divided by 2. Cancels each other out, but whatever I do to that side, I got to do to this side. So a is equal to negative 26 divided by 2, which is negative 13. And that means that a is 13. If you wanted to check it, you would do it the same way you did it over here. I'm going to do e with you as well. This is a little bit more complicated because it has decimals, but really do it the same way. As long as you're using a calculator, this shouldn't make a difference, right? So you have 2.5x minus 9 equals 1.1x plus 12. Treat it the same way. It's okay if there's decimals, just treat it the same way. I want to move and get rid of all of my variables on this side so that I only have the numbers on this side. So I'm going to get rid of the 1.1x. It's positive 1.1x. You're going to get rid of it the same way by subtracting 1.1x plus 12, right? Whatever you do to the right side, you must do to the other side. So you're going to do 1.1x minus 9, right? So I'm going to do 2.5 minus 1.1. And that's going to give me 1.4x minus 9 equals positive 12. So now I'm left with 1.4x minus 9. And I want to get rid of this minus 9, so I'm going to add 9. Whatever I do to that side, I have to do to the other. So I'm going to do 12 plus 9. 12 plus 9 is equal to 21. And then I have 1.4x over here. Same thing, even though it's a decimal, it's still 1.4 times x. So what I'm going to do is I'm going to do the opposite. I'm going to divide by 1.4. And I'm going to do the same thing over here. I'm going to do 21 divided by 1.4. 21 divided by 1.4, and x is equal to 15. So you're doing the same thing. And if I had to check it, I just go in and I draw, I'm going to put this in orange. I'm going to do 2.5, right? And it says that 15 is x minus 9. So I'm going to do left side first, right? Is equal to 1.1x plus 12, which is the right side. And I just want to make sure that they equal each other. So the x here is just going to be, I'm going to plug in the 15 for that. So let's solve the left side first. So I have 2.5 times 15, which is going to give me 37.5 minus 9. Just do 37.5 minus 9, and that's going to give me 28.5. And I'm going to do the other side as well. So I'm going to do 1.1 times 15, which is going to give me 16.5 plus 12 which is going to be 28.5. And left side equals right side. Therefore, we know you did it right. Okay. I'm going to do B with you, A with you. And then we're going to I'm not going to solve thinking with you today. We're going to do that tomorrow as a class. So I actually want you to try doing this by yourself, which is why I'm not going to solve it and post it. But try solving it by yourself, and we'll talk about your answer at the beginning of next class, and then you'll have this exit ticket to do. Just upload it into your portfolio, right? And I'll check it. All right. So what this is asking, and this is like a really great way for you to learn where you make mistakes, and I want you to start doing this for your own questions. So when you're going through these videos, or when you're going through the solutions on your own after, be like, okay, where did I go wrong? And why did I go wrong there? And how do I fix it? Right? So we have the solution to the two questions are shown below. Determine if the answer is correct. So let's start off with A, right? The first thing this person did was they did 5 minus 12 equals 3x plus 12. So what they did was they wanted to get rid of this 3x here. So I guess they did 3x minus 3x. Whatever they did on that side, they did on the other side. So that's correct. So I'd give them that 1 mark for that. They went ahead and they did 5x minus 3x. But for some reason, they wrote 8x. 5 minus 3 is 2. So that means they got that wrong. Right? So they would lose a mark for that. If we're going to continue, right, we're going to just follow their mistakes through. I don't know why they changed it to 2x here. That also doesn't make any sense. But what does make sense is that they took negative 12 plus 12 equals positive 12 plus 12. So that was right. But what they were trying to get rid of, so they did 12 plus 12, and that means that they got rid of the 12 on this side of the equation, negative 12 plus 12, so that equals 0. 12 plus 12 is 24. And then I guess they just brought the 8x back down here. You have 8x equals 24, right? If I was to follow this person's mistakes through, then yes, this makes sense, right? You took the 8, you divided it by 8x, crossed each other out, and you got x equals 3. If you're following mistakes through. But they made a mistake here, so we're going to fix it from here because this isn't a test and we want to fix their mistake. So starting from there, instead of 8x, you would have 2x minus 12 equals 12. Then you would have to get rid of this 12 on this side, which is 2x minus 12 plus 12. Whatever you do to this side, you got to do to the other side, so you're going to do plus 12 here, right? You have 2x equals 12 plus 12 is 24. And what you're going to do is you're going to get rid of this 2 over here. So it'll be 2 divided by 2. 24 divided by 2. X is equal to 12. Do you see how one little calculation mistake can lead to that big of a difference between the two numbers? Which is why I never mark you just based on your final answer. I mark your process. Okay, and which is why it's important that you show all your work. So let's try doing B. So try it by yourself first and then see where this person went wrong and fix the solution. Okay, so I'm going to give you a couple of minutes and I'll do it in orange after. Okay, welcome back. So I just hope that you had paused the video and you had gone through it yourself. So you have 8x plus 7 minus 3 minus 2a. So you have 8a and 2a. You want to bring the 2a to the other side. So this person did 8a plus 7 minus 7, which is fine, you can do it that way, minus 3 minus 2 minus 7. I wonder why this person did minus 2, right? Because it's 2a. And if this person had just left it as 2a, they would have a different number because they would have negative 3 minus 7. And it still is negative 10. But this is bad form. Okay, make sure you always write the a in. So I'm going to go in and I'm just going to say negative 2a. But they rectified their mistake in the sense that when they moved on, they did negative 10 minus 2a, which is still correct. So then they took the 2a and they moved it to the other, they added it here so that they could get rid of it on this side. Whatever you do to this side, you got to do to this side. 8a plus 2a equals negative 10 minus 2a plus 2a, which is correct. 8 plus 2 is equal to 10, equals minus 10. 10 divided by 10, because you want to get rid of that 10a there. And then it's negative 10 divided by 10, so a is equal to 1. So if this person was theoretically to go back and check their answer, 8 times negative 1 plus 7 equals negative 3 minus 2 times negative 1, you should get the same answer. So you have minus 8 plus 7. Minus 8 plus 7 is negative 1. Negative 3 minus 2 times negative 1, which will be negative 2, right, is equal to negative 3. A negative and a negative gives you a positive. Negative 3 plus 2 is going to be negative 1. Left side equals right side. So this mistake was really just here. They made a communication error. So I would probably take off like 0.5 of a mark because they fixed that later, but that was a mistake that they made. And that could have cost them. Okay, and that is it. That is our lesson number 2. Hope this helped. See you tomorrow.